on base flow. I think one of the things that's maybe a little surprising is that we don't see a big bump up during high flows, which to me kind of indicates that we're not getting contamination at a high rate picked up off the banks in the bed. That's the period when you're going to have scour and stuff and be suspending stuff out of the bed in the bank. So it's a successful program, and it will continue to be monitored. If there's still problems, there are probably additional things that can be added to the current capture system. By far the biggest remaining problem is, and I said this at the last presentation, it's definitely stormwater. And we'll see that. This is the Kelly ditch, and this is actually not a problem because this is routed directly to the Berkeley pit. So, but you can see what stormwater can look like. Nice and muddy. It's carrying a lot of suspended sediment. Next. And this is what it looks like on the streets a lot of times. Well, not a lot of times. This was a really memorable event, and I don't remember what it turned out to. Craig, do you remember? Did anybody ever figure out what that was? That event?
I think it was the 10-year precipitation volume in about 3 hours.
Okay.
Which is usually over 24 hours is how you design for that.
This is a big event. It really had a lot of water in the creek and coming down all of the drains.
Is that, where was the bottom part of that picture? Where is that right there, Joe?
That's, yeah, Front Main.
Front Main?
Yep.
Not quite Main.
Those are those homes, or whatever
Yeah,
they.
yeah, Triple S is right behind you.
Yeah.
You're right by the cable company.
Yep.
Yeah.
So, surface water. Here's the program. The ROD requires this best management practices program, and it is a sort of monitor, apply another management scenario, and monitor again. It also includes the part where you maybe chase a problem up into a tributary or into a storm drain. So it requires flexibility on how you monitor. The ROD also states that BMPs don't achieve the standard after this 15-year period, then they may just have to simply capture and treat contaminated runoff. And there is an additional part to that, because reality is you'll never catch every storm. So there is some kind of design limit that will limit what storms we can catch. We're obviously not going to catch the 100-year event and be able to manage it, but we certainly want to get it down to where we're getting almost all of the storms on a regular basis. So here are the tools in our toolbox, really. There's retention basins, or retention ponds. Hydrodynamic devices, I talked a little bit about those. Those are put in line in a storm sewer system, and it causes the water to, it's a centrifuge basically, and it spins the sediments out of the water to a certain size fraction anyway. You can't remove all suspended sediment. There's routing and diversion, and like I said, there's stuff getting routed to the Berkeley pit. That's obviously a great solution, but most things are too far down the hill to do much more. Actually, about everything that could be routed is being routed. Obvious one was reclaiming source areas. I don't know, I was having a discussion with somebody not too long ago, and they were real familiar with Superfund, and they were going, I got to ask you, what's left to reclaim? When you look at the Butte Hill, it doesn't look like it did 25 years ago. And it's a good question. It is pretty much capped. So I don't think there's much more to do on reclamation specifically. And then there's the storm sewer upgrades. Those are, they will be slip lining the trunk lines for the most part, and they're in bad shape. They definitely need it. It's kind of half part of remedy and half rebuilding Butte infrastructure really, which is in danger of collapsing in some places. So, next. So stormwater BMPs today, obviously, were capped a lot of ways. Most of the big areas are capped. And they were diverted, a lot of those upper hill areas are now diverted to the Berkeley pit. Missoula Gulch has a series of storm water retention basins on it, 3 of them. The MSD was reconstructed. I guess I would add to that because it's happening, curb and gutter, which is sort of a cap run-on, runoff control. And I would also add to that the hydrodynamic devices. There are some going in kind of right now. We're trying to get some in. We're also looking at a stormwater retention basin. And we're also looking at some additional routing. But next. So, what's it look like? Well, everybody here knows what that kind of looks like in that scenario. And it's real obvious that, you know, those rills are there because water was carrying sediment off of that slope and down to the creek. So, next slide.
Can you go back? Is that playground equipment?
Yeah, it is. You grew up here, Larry. This is one of the retention basins on Missoula Gulch. This is the last one. And I kind of wanted to describe this because I put model BMP because it's a model in my mind for the most effective BMP. The first thing that it does is it stops the water from rushing down and hitting the creek. So you've stored water, you've at least taken the peak off. In this particular case, if these are unlined ponds, all the water that infiltrates here actually is captured by the hydraulic control channel and is treated. So it's actually part of a capture and treatment system. This hydraulic structure here is built with so you can put plates in or orifices in. Right now there are plates up to about probably where this pond level is. And then right above that there's a little orifice, so it'll start spilling water at a fairly slow set rate. And then above that you have a big open structure. And then actually that storm event we looked at, I was actually up here standing on this thing, and this is an open grate at the top. And there, I was standing in about 6 or 7 inches of water because it was pouring over the top and into that grate. And then the last defense is this rip-wrapped emergency spillway right here. So you can see that you know, it has capabilities to manage water in different ways. So,
Joe, what are the plates for?
the plates are, so you have an open channel like this.
Yeah, right.
And then you put a plate in here, so it just seals it
vertical
off.
plate.
So you can raise the level in the pond.
Right, okay, gotcha.
So what kind of a storm event is that designed for?
What, 20,
I think it's the 10-year.
10-year,
24-hour.
24-hour? Yeah, that's right. And the routing to it and stuff is 25 years or something, isn't it? Or I can't remember how it goes. You're right, it is the 10-year though. The other thing to consider though, it's not as simple as saying capturing the 10-year event, because we get we get 1-year events stacked on the 2-month events stacked on the, you know, so. So here is the way that the drainages, the storm sewer drainages are laid out. They have nice little names. So you can see here's Missoula Gulch, pretty critical one actually to get control on. Here's where most of the reclamation occurred. It's large, and not only that, actually what is captured in that catchment system for Missoula Gulch also includes west side drainage, and it includes Idaho Street.